So what happens when there's an external force like friction? Then we do work. And the two equations for work are W equals Fd, which we're not going to use because we don't know the force in the distance, and W equals delta E, which we are going to use because we know that is energy final minus initial. And we've either done this with change in kinetic energy, which is final kinetic minus initial, or we've done it with potential energy, which is final potential minus initial. But here's the thing. It's not initial, it's not just kinetic, it's not just potential, it's both. So we need a new equation. We need a new equation to solve this. And this equation is going to be more thorough and is going to help us solve these things a lot easier. So we're starting with W equals because we're looking for a work equation. But what is work? It's a change in energy. So it's final energy minus initial energy. Well, the final energy is your kinetic and your potential added together. Just like your initial energy is your kinetic and your potential initial added together. Oh, sorry, it should be PE. So, all we have to do to put these together is put them together. Work equals change in energy. So, that's final energy minus initial energy. And put like a big box around this or something like that. Because that's the new equation we're going to use. Work equals change in energy. Okay, change in energy is final minus initial. And the final is kinetic plus potential added together. The initial is kinetic plus potential added together. So this is the main equation. So really, here's the equations we have for this unit. We've got the work equation. We've been using force of gravity. Gravity is 9.8, so that's something I'm going to give you. Then we got power equals work over time. We got our kinetic and potential energies. And then we've got two other energy equations. We got the basic conservation of energy, this one. And then we've got the work equals change in energy one. So work equals change in energy, which is this here, KEF plus PEF minus KEI plus PEI. So this is the big equation we're going to be using, okay? And this is the last main equation that we have for this unit. So roller coaster, just like the one we did for the last example. Roller coaster is at the top of the highest hill of 4 meters, travels down through a valley, then back up to a second hill that's 3.5 meters tall. However, because of friction, it stops when it gets a height of 3 meters. How much work is done? So, same basic premise here. Start up there, end up here. We start at a height that's 4 meters above the ground. The second hill is 3.5 meters above the ground, but it says I don't get that far. It says I only get to 3 meters. So, last thing I can put on there is the cart 0.5. So, we have a starting height. We've got an ending height. So the initial is up here. Final is here. The final is not at the top of the second hill. We don't make it that far. And then we got to decide where 0 is. So let's go ahead and make the ground 0. But some of you might like to make... Yeah, let's do a different color. Some of you might like to make 0 the final position. So I'll show you both ways. I'll show you the purple way and the brown way. So, knowns and unknowns. So mass is 0.5. Initial velocity is 0 because it starts from rest. Final velocity is also 0 because it stops at 7, it said. Or sorry, at 3 meters. Okay, we've got an initial height of 4 meters, got a final height of 3 meters, and then lastly we have one new thing, and that's work, which we don't know. Okay, if I'm doing it the brown way, so I have the same mass, same initial velocity, same final velocity. Now the heights are different. The initial height is not 4 meters above the ground. It's 1 meter above height of 0. So HI is 1. And HF is 0 because that's what I defined it to be. And work is still what I'm solving for. So the equation I'm going to use is this one here. W equals KEF plus PEF minus KEI plus PEI. So again, this is work equals change in energy, E final minus E initial. So in order to set up this equation, back to purple here. In order to set up this equation, I need to know what all these values are to plug in. Oh, this is final. I'm just all over the place. My bad, guys. My head is really hurting. There we go. In order to solve this equation, we need to know what all these things are. So we're just going to find them. So KEF would be 1/2 mv squared for the final velocity. So 1/2 mv squared. The final velocity we said was 0. Okay, then we do the PE final. MGH okay, the final height is 3. When you multiply that all together, you get some number. What did I get? I'll solve it real quick. I think it's like 14 point something. 14.7. Okay, now we do the initials. KE initial, 1/2 mv squared. It's the initial velocity, which is 0 also. And then PE final would be mgh. And again, the H final is 4. Or, sorry, this is the initial over here. The H initial is 4. So, plug the numbers in there they go. KEF is 0 plus PEF is 14.7 minus KEI, which is 0, plus PEI, which is 19.6. So we got to distribute this negative sign through the parentheses. So we get work equals 14.7 minus 19.6 gives you a work of 4.9 joules. Sorry, negative 4.9 joules. So what I want you to see is what this is nothing that you haven't done already. You've already done energy work stuff, and you've already done conservation of energy. This is just putting it all together. So you're doing the work and the energy conservation at the same time. Okay? And then this is, again, the big equation that you're going to be using. So go ahead and flip over to the back. And at the top of the page, let's just write that equation one more time so you have it. W equals KEF plus PEF minus KEI plus PEI. Okay, if you're done with the lab, I want you to start on the practice. If you're not done with the lab, I want you to finish the lab first. I'll leave my example up here so you can follow along with it. And then I'll come around here and see what questions you have, what you need help with. You should get the lab done and you should start on the practice. You don't have to finish the practice, but do get started on it. So I'll come around and see what questions you have and how I can help.